Because for and while are so similar, I took the while example and rewrote it as a for example, so I didn't have to explain it again. Enter a number, and now I'm using a for loop, int I equals 2. I don't need I after the loop, so I'm declaring it right there. The condition and the increment are what you recognize from the while. You're much less likely to forget to increment and accidentally write an infinite loop when you use a for loop, by the way. The body exactly the same, and we can break out of a for the same as we can break out of a while. And the printing out exactly the same. So let's run this. We'll enter a number. Let's try 25. 25 is not prime. Hopefully no one's surprised by any of these results. Let's try another one. 7 is prime. And just to demonstrate breaking out of the for loop, let's choose a number with plenty of factors. Let's try 24 this time instead of 12. First factor it finds when it's trying 2, it finds 12, not prime, breaks out of the for loop. So there you go. They're not importantly different to the compiler. Okay, for and while are importantly different to people, and the ability to control that scope, to have the loop variable disappear after the loop, is a big plus for many people. They don't really want to litter their code with a bunch of different loop variables, I, J, K, and I, J, J, blah. So being able to use one like this that comes into scope and goes out of scope can be a highly useful thing. And I have a little more guidance a little later on about for versus while. Switch really solves only one problem, but it's a problem that happens a lot. It's a pattern that's super common in your applications. And that's when you basically have a whole pile of ifs because you're trying to figure out which condition you're in. So if x is 1, do something or another. If x is 2, do something or another. If x is 3, do something else. And it's a little inefficient to do it that way because the compiler would keep testing. Once you know that x is 1, it can't possibly be 2 or 3, and yet you're testing your ifs over and over. So then people write nested ifs. So they write, if x is 1, do this, else, brace bracket, if x is 2, do this, else, and you sort of nest and nest and nest. It gets really hard to read. The switch statement is just a cleaner version that people can clearly follow. Here's the syntax. Other languages have this, but the exact word that's used varies from language to language. Where the brackets and braces and whatnot also varies. So we have round brackets around the expression, just as with an if, just as with a while. Must have an open brace immediately after that and a closed one, non-optional. And then you have one or more case statements, and each one of them is case, space, some value, colon, what to do, and then a break. And optionally at the end of it all, you can have a default, colon, and what to do. If you leave the break off, control just falls down and executes the next case for you, which is sometimes what you want, usually not what you want. Then you have a close brace at the end of the whole thing to say, okay, I'm all done with the switching. You don't have to have a default, so it's not like the compiler can say, oh, I processed the default, so I must be done. It needs that to let it know. You don't put brace brackets after each case because you keep going until you hit the break. So there's no need for braces after each individual case statement. The expression you're switching on needs to work out to an integer. It's very common to switch on the value of a single variable, but it could be some expression or an enum, which are integers behind the scenes. And the individual case statements you're testing against integer values also, or enum values. I have a demo of a switch statement, and I'm sort of pulling in some other things that we've already covered to make the demos a little easier to use. So for example, it's kind of annoying to have to keep running the demo 3, 4, 5 times to show the results of 3 or 4 different paths through it. I've decided to put this loop in here. As long as you enter some positive number, you just follow this brace down. You can see that the last thing that happens in the loop is I'll ask you again for a number, we'll hit the brace bracket, and we'll come back up and do this while again. That way, with a single run, we can test a number of different values. So what's happening inside the while loop? Well, we have this switch statement. We're switching on X, which is an integral type, so that's fine. Here's the non-optional open brace and the non-optional close brace at the end of the switch statement, and everything in between is our switch. And I have a number of different cases. So case 1, that is when X is equal to 1. I'll tell you that you entered 1 and I have a break. Something you'll see quite often is 2 labels right after each other, bang, bang. So 2 and 3 are right after each other. This is deliberate, and it means that you want to do the same thing for both 2 and 3. Since we're not doing anything real, all I can say is, well, you must have entered 2 or 3. But imagine a circumstance where you process both canceled and delayed things the same way. So you might have case canceled, colon, and then immediately case delayed, and then all the code to handle delayed and canceled, whatever these are. However, sometimes people do it accidentally, so I've simulated that accidentalism here with 4 and 5. There should be a break at the end of case 4, and there isn't, and I'll show you what happens when the break is missing. And then we have the defaults. So I'm going to run this through for a whole whack of numbers, obviously. Let's do that now. So if I put in 1, it says you entered 1, that's fine. If I say 2, you entered 2 or 3, and 3 will also say you entered 2 or 3. When I say 4, it says you entered 4, you entered 5. Let's flip back to the code. Because there's no break, it fell through to the 5 case and also executed the case for 5. Probably not what I wanted. We'll try 5, try something else, and finally 0, and we're out. The switch statement certainly takes up a lot less room than many, many nested else ifs, and it's more efficient than just if testing the same thing over and over again. After all, once we've established that X is 1, there's no way that it's 4. Also, stacking these up like this is more readable than combining them with OR. You haven't seen combining with OR yet, but trust me, this is more readable. So for certain kinds of architecture of your application, the switch statement is really useful. In modern C++, there are some alternatives, especially when you're working with objects and you have hierarchies. You can, rather than switching on something, you can have your objects be of different type and have an implementation of a virtual function in that type handle whatever this is. So you may not see as much switch statements, but when you see them, I want you to be able to read them, and I certainly don't want you writing big, long, nested else ifs when you could have just used a switch.